Welcome back to the series where I try to explain every element on a periodic table and show off what they are used for. In this video, we will go over the elements 81 to 90, from thallium to thorium. Starting off with thallium, a soft metal that is also toxic like mercury. It was used to make rat poison, as it is odorless and tasteless, but it has been banned for household use. This metal now is mostly used in photoelectric cells in electronics to convert light energy into electricity. The compound of thallium oxide is used to make glass with low melting points. Next, we have lead, a soft and corrosion-resistant metal that has been used ever since ancient Rome. Its malleability allows it to be easily shaped into things like water pipes and paint, but it is no longer used as it is quite toxic. Its high density makes lead a great element for making weights and shielding against radiation, but its most common use today is in lead-acid storage batteries, mostly found in cars. Next, we have bismuth, a metal with low melting point, making it useful in fire sprinklers and fire extinguishers. In case of a fire, bismuth will melt easily, triggering the fire safety device to spray water. Despite the metal itself being slightly pink, bismuth oxide is used as a yellow pigment in paintings and cosmetic products. Next, we have polonium, one of the radioactive elements that Marie Curie discovered. This element gets rid of static electricity, making it useful as a brush to remove dust from films. The isotope polonium-210, which is a regular polonium atom with an extra neutron, is rarely found naturally, so it's usually produced in nuclear reactors. It emits high levels of alpha radiation, as 1 gram produces up to 140 watts of heat energy, making it fantastic as a lightweight energy source for spacecraft. Next, we have astatine, a radioactive halogen that decays very quickly, as its half-life is only 8 hours. Due to this, it's only used as in research and cancer treatments occasionally. It's so rarely used that only 0.05 micrograms of astatine has ever been produced. Next, we have radon, the only radioactive noble gas that can be dangerous when inhaled, as the radon gas will decay into the solid radioactive polonium, causing lung cancer. However, small amounts of radon can also be used to treat cancer and in surgical implants. Next, we have francium, a highly radioactive alkali metal discovered in, well, France. This element is extremely unstable, as it decays into radium in only around 22 minutes, leaving this element with pretty much no usage. Next, we have radium, the other radioactive element discovered by Marie Curie, but has a much longer half-life, at around 1600 years. This element is used in glow-in-the-dark paint for watches and aircraft instruments. But since it's so radioactive, it's slowly getting replaced by safer elements to do the same job. Next, we have actinium, a radioactive metal that is very rare, as it is only found in small traces naturally in uranium ores. However, this element can be made by bombarding radium with neutrons in nuclear plants, and actinium is actually quite a good source for producing neutrons themselves. And lastly, we have thorium, another radioactive metal, but it is actually quite abundant, being as abundant as lead. Thorium oxide is used to make lanterns in high-temperature crucibles, as this compound has a very high melting point of 3300 degrees. Nuclear reactors powered by thorium are also under development, as this element may contain more energy than uranium. And there we have it, another 10 elements explained. I hope that y'all have learned something interesting today. Thank you for watching, and stay hydrated.